Hello and welcome to the presentation of team LU3DO, which stands for Light Up 3D Object. We have 5 team members. I'm Akshay, there's Hardik, Pinas, Uchit is behind the camera, and we also have Zohaib. Our slogan is we exist to empower people, and our mission statement is we build meaningful tech to help people and create a world without limitations by addressing visual disorders. After talking to our therapist Dr. Sam at BNI, we came up with a need and based a problem definition of that. Since we've already had a run through of this during the poster part of the presentation, we will be moving on to see which disorders we're looking at with this product. Firstly, we have unilateral neglect, which is an attention disorder. It typically occurs after brain injury, which can be something like stroke or brain hemorrhage. It occurs after an injury to the parietal lobe of the cerebral cortex, and about 10 to 80% of people who have right hemisphere stroke are affected by this, versus only 15 to 65% of people who have a left hemisphere stroke. The second disorder is visual field cut, which is blindness or reduced vision that is caused by damage to the optic nerve or the optic radiations. One of the main differences between visual field cut and unilateral neglect are that patients with visual field cut are aware of their condition, whereas someone with unilateral neglect may find it harder to be aware of their own condition. As you can see, this is the normal vision of a person versus a neglected vision. Now, these two examples are of unilateral neglect, and you can see how when they were asked to copy a drawing, they have only copied half the drawing, and when they were asked to spontaneously draw something, they have drawn the circle, but they have only drawn the numbers on half of the clock. This is what happens in visual field cut, where depending on the site affected of the optic radiations of the optic nerve, there are different kind of field effects that are associated with it. The third disorder that we're looking at is vestibular or balance disorder. So the vestibular system provides a sense of balance and the information about the body position that allows rapid compensatory movements in response to both self-induced and externally generated forces. So an example of this would be someone affected by this disorder will not be able to rapidly move their head left and right, which would affect how they're able to perceive or rather see the environment around them. The last thing is dual task cost. It is when a person cannot do physical activity correctly while doing a cognitive task. So in a therapy session like this, when a cognitive task is given to the patient, they are also expected to do a physical activity with it, which would be tough for them at the start, but over time it would replicate more real life scenarios. Moving on to the pre-existing treatments or products, we have 3 things. We have 2 products and 1 kind of therapy that is used currently. So the Blaze Pod is a wirelessly connected set of pods. They have an app, they're rechargeable, but they're only mounted on mirrors. As compared to the SmartFit, that is not just a light up object, it can also show different symbols. It has a progress tracker attached to the device. However, it needs to be continuously plugged in, and it can also be combined with portable displays, but they tend to be heavy. That's where the hallway card therapy comes in. You can print out giant cards and then attach them on different parts in the hallway where the therapy session is supposed to take place. This way we'll have more number of targets. It will be inexpensive, but it won't have all the functionality that these two do, like tracking, different modes, different symbols. And so we came up with our ideas. Firstly, we came up with a flip card display, which would have a simple flip display that after A it would show B, C, D, and it could show various numbers and symbols. However, we realized that the mechanism behind it would be too complex, and so we abandoned it, and then we moved on to other ideas. The most high-tech idea that we came up with was attaching a projector to the middle of the room, and then that would project all of these targets on the walls, and then based on us interrupting the light going to a particular target, we would get some sort of a feedback. However, as I mentioned before, it was too high-tech to explore, and so this is another idea that we came up with. It's very similar to how the Blaze Pods would look in a therapy session, in the sense that they're wireless, and they have one main control unit, which would typically be an app on a phone or a laptop. So we moved on to build upon that idea, and we decided that it would be more feasible to come up with something wherein there are secondary control units that are connected to the phone or the laptop, and these secondary control units are connected wirelessly, but they are connected to each display with a wire. And we can add further functionality to this by having an IR blaster headband attached to the patient, and so whenever they're trying to visually scan all the targets, whenever they see a target, that one would light up, or it would dim down, and that's the kind of feedback that they would get. So that is how we moved on to a final prototype, where, as you can see, we have created an LED display which can show the different alphabets. Here we've shown the alphabet Z, and it can also show different colors. And you can see that here two displays are attached to just one controller. And so based on that, the therapy session would involve a patient using the device and performing tasks that require them to work with the neglected side in identifying various numbers, letters, symbols, colors, etc. on the device. Now we will move on to the actual demonstration part. So now we will be moving into the actual demonstration. Here you can see that our first code here will show you how we've put in different numbers, letters and symbols. It will play a certain letter, number or symbol, and then have a delay so that you can see it for a couple of seconds. And then all the LEDs will turn off, and then we'll move on to the next thing. Now we will start with the demonstration of that. Here you can see the display light up, and it will now be going through the series of numbers first, 0 to 9. And then it will move on into symbols, and then it will move on into the alphabets. So this is one way that we can use the functionality, when there will be various things. We could even come up with some different characters that we can show up on such a display, and it will really give the therapist their freedom to choose what they want to show. Moving on to the next part, there is another display connected here. So on that we will be running a different kind of code, wherein we will be showing how we are using a photosensitive resistor to give different kinds of feedback. And in that way, we'll be able to show the functionality of the LED display and also how it can give us some feedback. And so as you can see here, first it's green, and then as someone moves closer to it, it starts to turn blue, and then it starts flashing in blue to show that a feedback is being seen, but it's not completely getting that feedback. And so once we come really close, it'll stop flashing to detect that it has detect that the feedback has been confirmed. And now we'll also show you the code part of it right here, wherein you can see that at first there's no feedback, and then there's a feedback detected, and there's a feedback confirmed. And that is how we can see both the displays working here. And we thank you for being a part of this demonstration.